All right, in this video, I will be showing you how to make a relative frequency histogram and an ogive graph. Okay, so blue group, welcome. Hopefully you're in your pajamas doing this. All right, so we had completed part one. Part one had all of our charts in them, and then part two is all the graphs. So what I'd like you to do is in the part one packet, you're going to turn to page 3. Okay, so this is page 3 of the part one packet. So page 3. And remember, we had done a couple of diagrams with the data on student mass. Now we've already done the student mass as a frequency histogram, and we made a frequency polygon. Okay, then we did an extra one, and then we went through a whole bunch of analyzing questions. Okay, so now I am on page 15 of your part 2 packet. Okay, but the part 2 packet picked up on page 9, so there isn't like a page 3 and another page 3, so they just kind of go all in order. All right, so on page 15, there are 2 more types of graphs that we're going to look at. The first is a relative frequency histogram, which has the same shape and same horizontal axis as the corresponding frequency histogram, but the vertical axis measures the relative frequencies, which is the percentages or the decimals instead of frequencies. So it's really, really similar. So I'm going to kind of pause with that, and we're going to go ahead and make one. So we're going to create a relative frequency histogram using class boundaries for 1A. So we're going to do this for student mass. So we're going to give it a title. So I'm going to do student mass in kilograms. So I'm on page 15. Okay, I like to tell you or to have you tell me how big your sample is. So we know N is 40. All right, and then on the x-axis, we're going to have mass in kilograms. Okay, so I'm looking at this table here. A lot of information. So this is page 3. And you can see we had all of the classes. We had our frequencies, we had our class boundaries. So we're going to use our class boundaries, and we're going to use the relative frequencies. So these are decimals, or you could think of them as percents. 5%, 10%, 18%, 25% out of 100, but we're going to graph them as decimals. Okay, and we're going to put our class boundaries on our graph. So we do want to go back one row as we're going through. So if you want to go back one row, you're going to remember this would be 44.5, and then our class width was 5. So you would subtract to get 39.5 to 44.5. This would be 0, this would be 0, and then the cumulative frequency, it would also be 0. All right, on our graph, I'm going to turn my paper, and I'm going to try to get this all in, and me. I don't know why. I thought I would let you see me. All right, so I have student mass here, and I'm going to put a break on my graph. So I'm going to do a little zigzag. All right, and then I'm going to put a line here, and that's where I'm going to put the 39.5. And then I'm going to start here at 44.5. And then we're just going to be going up by 5. So then I'm going to have 49.5, 54.5, 59.5, 64.5, 69.5, 64.5, 79.5, and I'm going to go out one more to 84.5. Okay, so pause it here if you need to. Otherwise, I'm going to keep going. All right, and then on the y-axis, I'm going to put relative frequency. Okay, and then since the relative frequency, I'm looking at here, the highest one I have is 0.25. I have enough room to do 0.02 as my increment. So that's going to be 0.02, 0.04, 0.06, 0.08, 0.10, 0.12, 0.14, 0.16, 0.18, 0.20, 0.22, 0.24, and 0.26. Okay? All right. Then, now what I'm going to be graphing is the relative frequency. So my first class boundary, my first group is 44.5 to 49.5. So that's in here. And I want to go up to 0.05. I'm going to go to a different color, actually. All right, so let me go to pink. So I'm going to do this here. All right, and then the next one, I have 0.10 for 49.5 to 54.5. Sorry if I have a misspeak. It's a lot to say. All right, the next one is 0.18, and that's for 54.5 to 59.5. So it's going to go all the way up here. All right, then the next one is 0.25. You're just going to keep going along. You could pause me or just listen to my voice as we go through. 0.10 is for 64.5 to 69.5. The next one is 0.15, and then the last one is 0.18. Okay, and now that is your relative frequency histogram. Okay, now we did a frequency histogram a couple days ago on the same data. This is page 9. So if you look from here to here, wow, they look a lot alike. That's because they're exactly alike except for the y-axis. So, and they should be. So I expect that they are going to look exactly alike. It's just that your y-axis is different. All right, so let's do a little analysis here. You could just say something that it's approximately normal. It's approximately normal. Most kids, so the mode would be around 60 to 64 kilograms. So most kids in the sample, let's say have a mass of 60 to 64 kilograms. Oh, I forgot normal. It's approximately normal. I mean, you kind of have another hump over here. So, I mean, if you're connecting it, you can kind of make an argument that it's approximately normal. You might say that it's bimodal if you wanted. You could say that, which makes a lot of sense because this is for all students. You have male students and female students, and typically speaking, the male students are going to have a larger body mass than the female students on average. Okay, so that is a relative frequency histogram. The other graph we're going to look at is called an ogive. Ogive. So an ogive is a cumulative frequency graph, still on page 15. It's a line graph that displays the cumulative frequencies of each class as its upper limits on the x-axis and cumulative frequencies on the y-axis. So when you do these, you're going to plot points. So the points is the upper class boundary, comma, to the cumulative frequency. Okay, so it's like X, Y. All right, so that means we're going to have to repeat what I just did on the x-axis because I'm going to use the same data for both of these. So now we're on 1B. We're going to create an ogive using upper class boundaries for the example 1 student mass. We're going to include a title. So we're going to have student mass again in kilograms, and it's still 40. We're going to label that at the bottom, mass in kilograms. All right, we're going to do the break. This time I'll do the break as a double tick, and then I'm going to start at the 39.5 and go all the way down just like we did a minute ago. Okay, so I'm repeating. Okay, I'm repeating using these class boundaries on my x-axis. Okay, so I'm going to keep going. I started with 39.5, so or you could just skip one and start at 44.5, then 49.5. You can do the uppers if that's easier. I would just start here and then go down. All right, you got 39.5, 59.5, 64.5, 69.5, a lot of numbers to say. 74.5, and I'm going to go a little bit more to 79.5. Okay, over here. Okay, and now on the y-axis, I'm going to put my cumulative frequencies. Okay, and if you look at the cumulative frequency, we're going all the way up to 40. So now I'm looking at this particular column. So since I want to go to 40, I'm just going to go by 5. So I'm going to do 5, 10, 15, 20, 25, 30, 35, and 40. Okay, so this is what you should have. Let me see if I can make that a little bit lighter. Much too. I was better off where I was before. Okay, we like it dark. All right, so now you've accomplished all of that, and now this is what we're going to graph. So we want to start with a 0 cumulative frequency here, but I want to graph the upper class boundary relative to the cumulative frequency. So to get a cumulative frequency at 0, you're starting at 44.5. So at 44.5, I have a point, and I'm going to call that 0, and I am going to go to my again. So I'm going to start here. All right, and then the next one is 49.5 and 2. So 49.5 and 2. See if I can get these side by side. All right, and then I have 54.5 and 6. 54.5 and 6. 59.5 and 13. 64.5 and 23. 69.5 and 17. 27, sorry, 27. I knew it was 17, that wouldn't make any sense. All right, 74.5 and 33. And then we're gonna end at 79.5 and 40. And then you wanna connect them to make a little line graph here. So what's nice about the ogive graph, another name for the ogive graph is a cumulative frequency graph, is that it shows you the increases. So an observation we might make for this data is that there is the largest increase. So the largest increase was from 59.5 kilograms to 64.5 kilograms. You can see that was our largest jump. Okay, so that is how you do a cumulative frequency histogram. So we reviewed relative frequency tables and cumulative frequency graphs. Great job. Thanks for watching.